But still in service, they must be bonded solidly together. That's why we put them in varnish and bake them in this oven for 12 hours.
Well, now, if you do that, though, that precludes any possibility of making any adjustments. They've got to be right when you put them in the varnish.
Oh, that's very true, Bob. The operation here, just before varnishing, of course, is what we call a preliminary test. Here we get the first electrical characteristics test on a very preliminary way to make sure that everything is all right and we're not going to have to take it apart again.
And that brings up another subject, testing and quality control. We'll talk more about it in just a moment after a few words from Hartley Sater.
You are viewing Success Story, a live on-the-spot telecast from selected locations in the greater San Francisco Bay Area, brought to you each week as a public service by Richfield. Tonight's telecast originating in the Sunnyvale manufacturing division of the Westinghouse Electric Corporation.
We've been talking something about quality control, and in this particular test station, I think we'll be able to see firsthand just one way in which quality is maintained here. What is the operation that's taking place here, Mr. Goodell?
Well, this is the second electrical test, Bob, that we're getting ready to make now. This is performed after the cores and coils have come out of their varnish and process treatment, and they're cured, and now they'll be given the second electrical test. And this electrical test, of course, is very complete, covering all the electrical characteristics that we designed them for.
How many tests are made altogether?
Well, there's 3 electrical tests, Bob. There's one more after this, which is the final one, and that performs all the electrical ones. There are, of course, many mechanical tests of the process and the specifications for the materials all the way through the line to maintain our quality of our product.
You know, I thought we were all done, but it appears there's still something to be added to our transformer, even after the varnish.
Well, Bob, this here is man is assembling a circuit breaker on this transformer. You might wonder what a circuit breaker is on a transformer. Well, Bob, this transformer has to have some protection, too, like our lights do in our homes, so we put circuit breakers on them.
It's like a fuse?
Just like a fuse. And that transformer is protected and won't fail anymore.
Is it complete now as far as the inner workings are concerned?
Basically, it's completely ready now, and it'll be, in the next operation, we'll begin to see them being put into their tanks.
Oh, I see. These are they begin to look a little familiar when you get them in the tank, or at least to the layman. Is there any particular characteristics of the tank that are important as far as transformer performance are concerned?
Well, they're nothing particular, Bob, except the finish. The finish on these tanks is probably a little unusual. It has 3 coats of paint, like probably most everything else does. But that inner coat of paint, Bob, is very special. It has a ground mica flake ground up in the pigment, and that is very protective to the corrosive atmospheres of our transformers that we require in this country.
Well, now it's disappeared into the tank. I think we ought to go back once more and review the component parts that have gone into that tank as we saw them being made and assembled here. Would you identify them for us, Mr. Goodell?
Well, on this transformer here, we saw it being completely assembled as a coil, the core blocks, and the frames. And later on, we saw them putting on all this hardware here, the tap changer. And from that point on, of course, it went into the oven and was treated, all in the varnish protection. Then we assembled this circuit breaker here, which we see here as a part. And after that's been assembled, it has been now ready for the lowering in the tank.
Once we've got it down in the tank, what do we do? Just seal it up?
No, there's too many important operations left yet, Bob. And the primary one is to put that oil in we've been talking about.
Now, just what does the oil do as far as the operation of the transformer is concerned?
Well, first, Bob, this oil is a very special high-insulating oil. It has 2 primary purposes. The first purpose, of course, is to keep out unwanted moisture, and that's very important in the transformer. Second thing is to radiate the heat that's generated while it's in service.
So it cools and insulates, too?
That is right, Bob.
Well, now, you say that air carries moisture and the oil keeps it out. Suppose there are air bubbles trapped down the bottom of that thing when they pour the oil in.
Well, that's why we have this sample unit here to prove out our processing, Bob. We put it in a vacuum. And actually, this little sample unit is on a vacuum process now, pulling out the air bubbles, which accumulate in any operation. And they must be taken out because on every air bubble is moisture, and moisture is detrimental.
So if you put a vacuum on this, now the air tries to escape, and you get rid of it in the oil.
It gets rid of all of it, Bob. So there's nothing left in there but of oil in all the interstices of that transformer.
Well, now, we understand that this is merely a test stand that we're seeing here. How do you actually do it in production practice?
Well, in production practice, Bob, of course, we have to have much bigger vacuum tanks. So here we see a man who's just loading an oven. It's got 40 distribution transformers in it. Now those transformers are all been filled with oil, and he will now lower the big gates on that oven, and a vacuum will be pulled down there to about 29 inches, and it'll stay in there for 2 hours. And after that, all those air bubbles will be gone, and the transformer's then protected.
And once that's done, it doesn't have to be done again. In other words, the air can't get back in.
The air cannot get back in unless it's been taken out.
It's a far cry, however, from these vacuum tanks that we see here for the small distribution transformers to the huge pits on the other side for pulling a vacuum on the big power transformers. In fact, if I understand correctly, that whole assembly that we see coming out there is one power transformer?
Yes, Bob, it's one power transformer, but it's a relatively small power transformer. Even though it's coming out of the floor like it is quite large because they are very large in physical size. Actually, Bob, this unit right here now weighs 22 tons. And when it's complete in its oil and its tank, it'll weigh 33 tons. But gosh, just think when we make one that's 25 times bigger than that, what it would weigh.
What would a transformer like this cost, you suppose?
Well, a transformer, this particular one here, Bob, would cost probably just under $100,000.
Expensive machinery and very impressive, and yet with all its size and bulk, if I understand correctly, it contains the same basic parts and performs the same basic function as the little distribution transformer we've been following.
Exactly the same. The principles of transformers are all alike, just different for different applications.
Mr. Goodell, thank you very much for bringing us this far. We'll see you a little bit later with some more very interesting information. But now, ladies and gentlemen, I'd like to introduce to you Mr. Walter J. Matham, the Pacific Coast Vice President of Westinghouse. Mr. Matham, it's good to see you again.
It's good to see you again, Bob, and welcome back to our Sunnyvale division.
You know, we've seen and learned a lot about transformers tonight, or at least we feel like we have, but I suspect that there's a great deal more that goes on in the background that we couldn't possibly see in a half hour.
Well, that is right, Bob. Behind all of this, many years of research and engineering and production achievements. Take, for instance, our latest development in the installation of distribution transformers. Behind this represents about 8 years of intensive research and development and exhaustive field tests.
Well, Mr. Matham, wasn't the Westinghouse Company one of the pioneers in the field of manufacturing transformers?
Yes, that is right, Bob. George Westinghouse, the founder of our company, together with William Stanley, one of his design engineers, designed and built and demonstrated the use of the transformer back in 1886. As a matter of fact, a lot of people mark that time as the age of the electrical industry.
Well, that would make the transformer a tremendously important item in our daily life, in fact, in our whole civilization today.
That is right. The heart of every power and distribution system is the transformer. You might say that because of the widespread use of electric power that is brought about by the use of the transformer is one of the reasons we have this high degree of high standard of living.
Well, certainly it's been a fascinating subject for us. And another thing, noting the skill and the enthusiasm, the people that we meet here, certainly the Westinghouse organization must be proud of this Sunnyvale manufacturing division.
We certainly are, Bob. This plant was established to better serve our customers here in the West. It's one of the largest plants of its kind. As a matter of fact, it is the largest plant devoted to the manufacture of electrical apparatus west of the Mississippi River. There's over 1 million square feet of floor space under roof, and we do devote a lot of attention to the manufacture of various products. As remember, you were here not too long ago, and you saw the various lists of products manufactured in our plant. But beyond all that, we are more proud of the people here at Sunnyvale. And I'd like to have you meet Jim Hagan, the manager of our Sunnyvale division. This is Mr. Hagan. Bob?
Fine. Thank you, Mr. Matham. Mr. Hagan, it's been a pleasure. And while we know that the transformer manufacturing is a very important part of the work here, we also realize that Westinghouse is concerned with many other things here at the Sunnyvale plant. Are there any of them you can tell us anything about?
Yes, I think the most interesting we have today is the development of the launcher and handling equipment for the Polaris missile for the Navy.
Well, certainly we've all heard or read about that. That's the, if I'm not mistaken, the guided missile they launch underwater from a submarine. Is there anything else along this line you can tell us about?
Yes, we have just finished and shipped 5 atomic submarine power plant equipments. The reactor itself was built at Bettis Field, but all the other equipment was built at Sunnyvale.
Where will the subs themselves be built?
The subs will be built part on the East Coast and part at Mare Island.
Now, getting away from the field of defense, what about applications in the industrial field?
Well, the field is very, very wide as far as we're concerned at Sunnyvale. We're building turbines from 5,000 kilowatts to 156,000 kilowatt giants. Here's a motor, an 8,000 horsepower motor, the largest built in the West. It's built by the Utah Construction Company for a dredge.
Well, certainly we can't help but be impressed by this terrific display of widely varied things that I see off here to my right.
Yes, you have a wide variety from a home heater to the large circuit breaker in the distance.
Well, now, all of these things must represent a combination of the knowledge, the technical skills of your engineers, and the skills of the workers right here in the plant.
It's true, I think, that our biggest asset are people. In Sunnyvale, you couldn't possibly produce the wide variety of products if you didn't have years of experience and a great deal of design know-how, and our people in Sunnyvale have it.
Fine. Thank you very much, Mr. Hagan. It's been a real pleasure to visit the plant.
Thank you very much, Bob.
Now what we're going to see, ladies and gentlemen, as I think an exciting climax to our show is 2.5 million volts of man-made lightning. Actually, it's not too hard to demonstrate 2.5 million volts of lightning, but to build the equipment to produce it is a very costly thing, and that's why Westinghouse is the only organization in the West that can boast of an installation such as this one, which is used for the testing of the transformers made here at Sunnyvale. Right now, power is building up in this device behind me. In a moment, we'll hear the warning horn, and you'll see what happens, so keep watching. In the meantime, what's the purpose of this test, Mr. Goodell?
Well, Bob, the purpose of this man-made lightning test is to develop on this surge generator, as we call it in our industry, to simulate lightning. Well, why do we simulate lightning, Bob? We have it around the country, as you and I both know, and therefore we have to make sure that what the features that we design in a transformer to assure ourselves that it is going to be built there and is going to stand the test in the field.
I think you proved your point, Mr. Goodell, as we saw the lightning flash from the top of the insulators to the pole here, and it certainly was a very exciting climax for our show.
Well, Bob, I hope that this has proven to you through our little trip here tonight why and how we can make this transformer useful to you as a personal individual in a home. You notice this little home here, the lights still work, the lightning hit this transformer on the pole, and everything is fine, so you can continue on and enjoy your electrical living.
Fine. Thank you very much, Mr. Goodell. Ladies and gentlemen, it's entirely within the realm of possibility that a turbine generator built by Westinghouse provides the power for your local power company. It's also very possible, even probable perhaps, that this power then passes through transformers built by Westinghouse and is measured by a Westinghouse watt-hour meter. From here, the electricity may be used in a Westinghouse light bulb, TV set, a range, refrigerator, or other home appliance. Circuit breakers, switchgear, and other control devices protect and safeguard our electric power supply. And thus we are proud to salute an organization that so often touches our daily lives, serving as a continuing example of progress and achievement on Success Story.
Success Story, an on-the-spot live telecast from selected locations in the San Francisco Bay Area, is brought to you each week as a public service by Richfield, makers of Rich Lube 1030 motor oil, new Richfield boron gasoline, and a complete line of years ahead Richfield petroleum products. Next week, our cameras take us for a dramatic visit to the great Kaiser Aircraft Corporation in Richmond, California. Be sure to join us next Thursday, 6:30, and until then, this is Hartley Sater saying good night from Richfield.